Okay, we'll find the derivative for 2 times cosine x times sine y, that's equal to 14. And since the y is not isolated, it's okay, because I don't want to isolate it either, because we can use implicit differentiation. And before we do that, we notice we have 2 times this, and that's equal to 14. Let's go ahead, divide both sides by 2 first, so that we can reduce the number a little bit, right? So this is now cosine x times sine y, and that's equal to 7. From here, we can go ahead and put down dx to represent that. We are taking the derivative with respect to x. However, on the left-hand side, we have to do it carefully, because this is cosine x times sine y. To take the derivative of a product, be sure we use the product rule. We are going to first keep the first function, so that's cosine x, and then we multiply by the derivative of the second. Derivative of sine is cosine, and we make the input states the same. And then we multiply by the derivative of the inside, by the chain rule, right? Derivative of y with respect to x is the dy dx. And this is how we squeeze out the dy dx. And this is just the first part of the product rule. And then we are going to add the second function, namely sine y times the derivative of the first. Derivative of cosine x is negative sine x. So I'll put down parentheses, negative sine x, like that. And that's pretty much it. And for this, you don't have to multiply by dx over dx, because that's technically equal to 1. So that's pretty much it right here. And then the derivative of 7, the derivative of a constant 7 is just 0. So this is equal to 0. So that's all we have. And now we are just going to isolate the dy dx. We have this on the left-hand side. Let's go ahead and write this down. Cosine x, cosine y. I cannot combine anything because they have 2 different inputs. I'm not going to combine them neither. So I'll just write this down, and then this is the dy dx. I am going to move this to the other side. This was originally negative because we have the negative right here. Move to the other side, it becomes positive. And we will have sine x times sine y. And then from here, we can just divide both sides by cosine x, cosine y, so they will cancel, and then we do the same thing right here. Cosine x, cosine y. And in the end, we see we have the dy dx being isolated, and sine over cosine is tangent. So the first is tangent x. And then here, this part is going to be still tangent as well, but the input is y. And you can just leave the answer like this. The answer is tangent x times tangent y. And that's it.